So today we're going to take a look at some complex ones. So if you look at our axes, now we have a real and imaginary. So consider the complex number 3 plus 2i. What is the real part and what is the imaginary? So our real is 3. Our imaginary is the 2. So in the complex plane, the horizontal is the real and the imaginary is the vertical axis. So graph the point. So 1, 2, 3, 1, 2. So that is 3 plus 2i. So what are the coordinates of that point? In rectangular would be 3 and 2. What are the coordinates of this in polar? Okay, so polar again is our radius and theta. So to find our radius, let's see, it's like making that triangle, so 3 and 2. So 3 squared plus 2 squared equals r squared. So that would be 13, so the square root of 13 equals r. And then we have to do that trig, right? Inverse trig. And if I do that, I get approximately 0.588 radians. So in polar land, this is the square root of 13, 0.588. So a complex number is represented using the 0.4 and 5.4 and 5 pi over 6. So 5 pi over 6, so in that second quadrant, 1, 2, 3, 4, okay. What is the real component? Okay, so we have to graph this again, okay? So we know that this is 4 and 5 pi over 6. All right, so we have our x and our y again. Okay, so let's see. So the real is our x value. So the cosine of 5 pi over 6 equals x over 4. So 4 times the cosine of 5 pi over 6 equals x. So that would be 4 times root 3 over 2. So 2 root 3. And imaginary is our y part, okay? So the sine of 5 pi over 6 equals y over 4. So 4 times the sine of 5 pi over 6 equals y. So that'd be 4 times half. So 2 is our y component. So in complex form, we have our real plus our imaginary. All right, so just like size or magnitude of a number, its absolute value is the magnitude of a complex number. So what is the magnitude of 1 minus 4i? So 1 minus 4. So 1 squared plus negative 4 squared. That's our magnitude squared, or our radius. So that would be the square root of 17. Okay, so we have this real and this complex plane. So if you needed to graph this, you go over 3, 1, 2, 3, 4. So there's 3 plus 4i. So this point would be negative 4 minus 3i. So the formula is very, very similar to what we did. How do we find that real, that radius, and our theta? Well, just like we did above, it's that Pythagorean theorem again. And our theta, we have to do that inverse tangent to find our angle. And again, you can always graph these as well. So negative 3, the square root of 7. So our radius, negative 3 squared plus the square root of 7 squared. So that's 7 plus 9, so that's 16 equals r squared. So r is 4. And then our inverse tangent, that tells us it's negative 0.722 on our calculator, but that tells us in this quadrant. So to get to that other quadrant, we have to add pi. So we have 2.418. All right. So then the way that we write this in complex polar form here, okay, is r times our cosine of theta. So it would be 4 times the cosine of 2.418 plus I 4i plus the sine of 2.418, okay? So maybe we should back up a little bit here, and we're just going to go over rectangular and complex form. So, convert regular to complex. So this is like, excuse me, sorry guys, I jumped too fast here. So this is a plus bi goes to r cosine of theta plus I times r sine of theta. So that's polar form of it, all right? This first one is rectangular form. So when we look at this, 2 minus I over 2 and down 1, we need to put it into polar form. So again, we have to convert it to this polar. So our radius, well, that would be the square root of 3, right? And then if we look at this next part, let's see our tan inverse. That tells us negative 0.463, and that would be in the correct quadrant. So we have r, so the square root of 3 times the cosine of negative 4.63 plus the square root of 3i times the cosine of negative 0.463. And there's our polar form. So going back the other way, it's that same type of thing we did before. Our x value is r times the cosine of theta, and our sine is r times the sine of theta, okay? So, and again, we could plot this just to see where it is. So we know that it's pi over 3 in this quadrant, and we want to find our x and y. So we're going from polar to rectangular. So that's going from r cosine of theta plus ri sine of theta to a plus bi. So we have to find our a and our b, or our x and our y. Okay, so the cosine of pi over 3 equals x over 3. So 3 cosine of pi over 3. So that'd be 3 times half, or 1.5. And the sine of pi over 3 equals y over 3. So 3, the sine of pi over 3 equals y. So 3 times root 3 over 2. So 3 root 3 over 2 is our y value. Okay, so this one, it's the same thing, it's just in factored form. So there's our radius, and there's our angle. So 3 pi over 2 and 4. Well, that's pretty easy, because there's no x movement, right? So it'd be 0 minus 4i, because it's just going down 4.